now we're happy to show spotlights of two of our early stage IA winners, MultiOn, and we have founder and CEO Garg here, and Factory, and we have founder and CEO Matan Grinberg. So MultiOn is an AI agent platform whose vision is to automate tasks in the background of any digital experience. And Div comes to us. He was a PhD in computer science from Stanford, is a lecturer there, and was previously a roboticist at Cobot. And the MultiOn is backed by General Catalyst, Forerunner, Amazon, and more. And then immediately afterwards, you'll hear from Matan. And so Factory is looking to massively streamline the software development lifecycle using fully autonomous programmable droids. So these are the droids you're looking for. And Matan previously was a high-energy physicist researcher and an AI researcher at Berkeley, and they've recently raised $20 million from Sequoia, Lux, and others. So with that, we'll bring Div up to stage to tell you more about MultiOn. Thank you.
Cool. Hello, can everyone hear me? Cool. So very excited to be here. So my name is Div. And I will be talking about AI agents that we're building at MultiOn. So we see AI agents as the new interface to the digital world. So our product leads very nicely to visual demos. So I'll be showing a lot of different things you can do with our agents, from booking flights to reserving restaurants to passing the California driving exam. So let's get started. So in this case, the agent is controlling my browser. So I've given it full access to my Chrome. And so what's happening here is it's been given a prompt to book a flight from SF4 to New York. And the agent here is going and doing that for me. It knows a bit of my preferences. So it knows that I like United flights, that I like economy. And then it's going and doing this. This is fully autonomous. So I'm not touching the keyboard, the mouse. It's the agent that's controlling my browser. And it's showing on the chat on the right what's happening. In this case, the agent knows that I like window seats. So then it can go and choose a window seat for me. And finally, it can go and check out. So it can go end-to-end buy the whole flight. And so here it presses the buy button. And then you can actually see that I have the flight booked end-to-end on United. And this was fully done autonomously, where the agent was controlling the browser. In the demo, we are showing everything happening locally, but this can run in the cloud. So this can be running headlessly anywhere you want. This is also one of our older demos, so this is slowed down in purpose. But now our models are much faster, I would say 5x faster. So this can happen much faster than human speeds. Cool. Next. Everyone has used LLMs. The question is basically, what happens next, right? Now imagine a world where there's every single person has one agent. Now, how do we go and build a safe future for humanity in that case? How do we put in the guardrails? How do we ensure nothing goes wrong? And how do we deploy the systems at large? A good example is something like CrowdStrike. So if you still remember that, there was one single point of failure that caused all of Microsoft to crash. We don't want something like that to happen. And agents are potentially risky. They're intelligent. They are dynamic. They're doing things in large. And so you want to make sure that, OK, this system's a control. They don't accidentally cause a massive havoc to society. And this is what we're doing as a company at MultiOn. So we're building these AI agents that can go and handle tasks in the background for any kind of digital experience. That's happening in the browser right now. In the future, we are looking to also extend to maybe other systems like desktop and other sort of modalities. We have an amazing set of investors who have been supporting us on our journey. We started 1.5 years ago when I was a PhD student at Stanford. I subsequently dropped out. And we're just glad to have found an amazing set of employees, investors, and other members along the journey. Now, the point I want to make here is AI agents are what self-driving cars are to the digital world. Now, what do I mean by that? Let me show you. So this is a feature we got in This Week in Startups. If anyone here knows Jason Calacanis.
So let's get right to it.
Okay. All right. So the first one, I'm gonna put something out there, J-Cal. This is gonna be an A+. I'm gonna predict it to be an A+.
Predicting an A+. Okay,
Yes,
here we go.
I'm gonna predict it to be an A+. All right. So great set of founders, come with an incredible background. The company is called MultiOn. And so
MultiOn.ai.
yeah. And the way it works is it's a Chrome extension. It's pretty invasive because you have to give it full control of your browser, but it's super powerful. And so what I'm able to do, I'm going to start here and say, book a meeting tomorrow with Jason at 2 p.m. And what you're going to see it do, it's going to kick off. And it can read it to you, and it's good. It's been like, yes.
Holy cow. For people who are not watching, the Chrome extension has taken over the browser. The inmates have taken over the asylum, and it's popped up essentially a co-pilot, opened up Google Calendar. It knows how to click on Google Calendar, and I've given up control of my browser, and it's set up the meeting. Oh, my Lord.
Yes.
That was incredible.
Cool. So this is kind of the reaction we get. And so if you think about this, if you've ever driven a Waymo in SF, it's basically like when you see self-driving cars on the digital road, on the physical roads, you kind of have this magical experience where like, okay, now this car is driving itself, like things are happening, I don't have to do anything. And it's kind of the reaction we are starting to get when people use our agents, where like, okay, this is kind of like a self-driving car for your digital world, for the internet. And then you don't have to do anything. You just sit and relax. You tell your computer, OK, this is what I want you to do. And things get done. And this is kind of the magic that I think will be fascinating to watch as agents start working in the real world.
Cool. So let's get right.
As a company, we are very innovative. We have been building a lot of our core innovation. We have been actively training models. And we look to be on the forefront of AI and agents. So one core capability we launched recently was called Agent Q. This is a novel method that uses reinforcement learning to create agents that can plan and self-correct. There's 5 levels of autonomy for agents. There's level 0 to level 2, where a human is in control, and level 3 to level 5, where the agent is in control. And in level 3, there's still a human in the car when it comes to self-driving cars. And the human is there as a monitoring mechanism. So it's like it's watching the environment and making sure nothing goes wrong. And this is the paradigm we are starting to reach, where like if you think about like what ChatGPT, what Claude, like what other kind of chatbots are doing, they are at this L2 level, where like you start to see some sort of automation, but still like the human giving the prompts, driving everything. What we are trying to do as a company is work on this L3 area, where you might still have a human in the loop, but that agent is going and actively taking decision making, it's doing things for you. There's a lot of ways to think about these agents. There's a lot of different capabilities you have to build. So it's a very complex system. It's just not the model itself. You have to think about memory. You have to think about like how do you do planning? How do you take actions in the environment? And how do you maybe like add tools like calculators, calendars, similar to what a human will use. Finally, let me show you this demo. So in this demo, what we are doing is we have our AI agent going and taking the actual DMV car exam. And so what's happening in this video is we have a human who has their hand above the keyboard. They're not actually touching the keyboard. We're just trying to trick the examiner here. And there's like 40 questions on this task. The agent is actually able to go and answer all of this correctly. So it's solving this MCQ exam live. In this case, there was actually a webcam that was recording the person. We had to install some sort of like screen recording software. And like there was like a bunch of things. Well, surprisingly, we still passed the test. And the California, like DMV actually sent us a driving license at the end. So that was really fun. We had to blur out some of the details because of personal information. We let the DMV know that this was not a human doing the test. But we were still lucky to get a driving license we can use. Cool. So we see 3 agent platforms of the future: the mobile, the desktop, and the web. And we see the web as the most important one, just because the internet needs to be reimagined for agents, because the internet was made for humans. And 90% of the things you do on a desktop happens in a browser, where you're like manually interacting with websites, you're manually doing a lot of things online. And this is what we're trying to change at MultiOn. We're trying to build agents that can go operate on the internet on your behalf and build like web agents that might be the next generation of capabilities for a lot of AI to start working for you and doing like very useful things. And this is what we're trying to enable. You can come find me later if you want to see any live demos. We have a bunch of things we have released so far. We have an online platform where you can try our agents. We have a lot of new things also coming out in this month. Thank you.
Hey, everyone. I'm Matan, CEO at Factory. And who's Factory? So Factory is an AI startup based in San Francisco. Our mission is to bring autonomy to software engineering. And what that means more concretely, we are building an AI platform to optimize and automate the software development lifecycle. In particular, tasks in the software development lifecycle like testing, debugging, refactoring, migrations, review, documentation, a lot of the things that developers typically don't like doing, but unfortunately spend a lot of their time on. So speaking of the software development lifecycle, typically it looks something like this. On this journey from idea to product, it's extremely messy. It's very inefficient. You could say it kind of looks like a maze. Oftentimes when we show people this, they'll say that actually they wish it was this simple, and typically it's even more complicated than this. And so the AI tools that have existed thus far are aimed at speeding us up on this journey from idea to product. But speeding up along a maze, unfortunately, is still quite inefficient. And a visual way of understanding our mission to bring autonomy to software engineering is we really want to streamline this process and turn it into something like this, where we've made somewhat, there's of course gray area between some of these steps in the software development lifecycle. Knowledge, if you want to do a certain task, you first need to understand your code base, your engineering system, why certain decisions were made. And once you do that, then you can move on into the project planning step. Once you plan out a project, you'll go in and start coding. Some orgs test first, some review first. But in general, this is the streamlined outline of the software development lifecycle. And what we've spent the last year on is building state-of-the-art autonomous agents focused at each of these individual tasks. Importantly, however, there are kind of 3 different work modes that have emerged in this AI for code world. And so the first one is predictive autocomplete. This is tools like Copilot that we're very familiar with. The second is pair programming. And so this is where you might have your editor open and a tool like ChatGPT open, and you swipe between them. You use this AI assistant for chat-based ideation, planning, knowledge. And then this third category is really what we've brought to the bleeding edge, this autonomous delegation. Importantly, the software developers of the future are not going to do just one of these things, nor are they going to do just 2 of these things. But instead, they're going to be dynamically switching between these and fluidly as they're going about whatever software development project they're working on. So a concrete example of this, so suppose you're a large organization that's doing a very large migration project that involves thousands of files. You might get started and first use this pair programming work mode to understand what part of the code base, what files are relevant, and how you might go about doing that migration. Once you have that plan, you can delegate some of these sub-steps to autonomous systems to go and take on those sub-steps, while at the same time, there might be some mission-critical steps that you want to jump in on your own and do that faster within the IDE with an autocomplete tool. And so this is actually, funny enough, this is the very first time we're publicly talking about this, but we have built a platform called Assembly, very intentionally called Assembly, that is the new home for software development, where you can seamlessly do all 3 of these work modes. So how do we actually do this? The key thesis here is that to do any of these tasks well, you need deep understanding of not just the code base, but the entire engineering system. So that includes your source code manager, your project management tools, and your communication tools. Just how we wouldn't expect a human engineer to jump into your code base and start contributing without first adding them to your source code manager, onboarding them into whatever tools you use for communication, and getting them familiarized with Jira or Linear or whatever project management tool you use. And so it's kind of unfair to assume that an AI system could produce meaningful code without having similar access to these tools. At the same time, these systems need the ability to reason about this information in a way that mirrors how we as humans do. And so, semantic similarity over a vector database, while helpful, is not enough and not a good proxy for how we as humans reason. And so what we've done is introduce other information sources like knowledge graphs, static code analysis, dependency graphs, that allow these systems to reason in a way much closer to how we do. And then at the same time, we call these cloud droid environments. These give these autonomous systems the ability to actually execute code. Because I'm not sure about any of you, but if I had a task that I had to code up like 3 files and I wasn't allowed to execute code at all, I'd be damn sure that it's not going to be correct at the first try. And so it also wouldn't be fast, right? Like, I code much faster if I can intermediately execute code. And so why would this not be the same for autonomous systems? And so that's what's really informed building these cloud droid environments. Also, just an amusing fact, the retrieval system that we've built for this, we call ByteRank, and somehow that has not been trademarked until us, which is kind of a fun little tidbit there. So this is kind of reiterating the point about the software development lifecycle earlier. Here are the most common use cases that we've seen within the enterprise. Importantly for us, we are focused on delivering this value not just to solo developers who like to try every new tool that comes out, but mature enterprises where engineers spend 90% of their time not on fun, sexy things like building an app from scratch, but very tedious, very unsexy things like migrating, COBOL that, the last engineer who touched it was like 30 years ago. These are the kind of tasks that we're focused on. And this is, extremely hand-wavy here. Like, getting quantitative on this is obviously very highly dependent on the organization that you're working with and how they, measure time spent on certain tasks. But, with broad strokes, this is what we've been seeing so far in terms of the ROI. And importantly, I think, as we build this, most of the comprehensive studies on engineering productivity come to the conclusion that the highest R-squared correlator with real engineering productivity is developer self-reported productivity, which is also happens to be probably the easiest thing to measure. So that's generally what we hang our hat on. And yeah, that's a general overview. Not enough time to go into a live demo, but I have my laptop and would love to show some folks if they're interested. And thanks, guys.